In the previous videos, we learned about vector addition and vector subtraction. In this video, we're going to learn about vector multiplication. We can multiply vectors in two different ways. One gives us a scalar product and another one gives us a vector product. As the name suggests, the scalar product is a scalar, the product is a scalar, and vector product, the product is vector. Let's learn a little bit more detail about these products. The first one is scalar product. Other way to call the same thing is dot product. Okay, so imagine that you have two vectors, vector A and vector B, and they're at an angle theta. Okay, so the dot product can be written as A dot B. So this is how we always write the dot product, A dot B. And that equals the magnitude of vector A, so we don't have to put an arrow on top, times the magnitude of B times cosine of angle between them. Okay, so if we have A as the displacement vector having 2 meters in that direction and the force is 5 Newton, then we can calculate this dot product as the magnitude of A is 2 and magnitude of B is 5, and cos, if I take the angle as 30 degree, cos 30, and that equals 8.66. So what's the unit? The unit of A times the unit of B. So the unit of A is meter and unit of B is Newton. So that's unit is Newton meter. As I said earlier, this product is a scalar. It doesn't have any direction. If we look carefully at this dot product, it can be read as A times B cos theta. So what is this B cos theta? If you look at this diagram, we can split this B into two components, one along this direction and one perpendicular to the direction, two perpendicular components. We already learned that in a previous video. To split that into components, construct a right angle triangle with vector B as the hypotenuse of the triangle. So this is one and then this is the another component, and this component is, if this angle is theta, this component, the adjacent component, is B cos theta, and this is B sin theta, which is not relevant in here because we're looking for B cos theta. So basically this dot product is the vector A times the projection of vector B onto the vector A, or the first vector, vector A, times the component of vector B in the direction of vector A. Okay, so what is the physical significance, or what is the use of this dot product? Where can we use this dot product? So for example, if in this case, X is 2 meter and F is 5 Newton, so that can be viewed as, okay, so we have a suitcase and it's dragged along the floor by applying a force in that direction, and the suitcase is moving in this direction by X. To find the work done by this force, what we usually do is, work done is force in the direction of the displacement. That's the force that we count when we calculate the work done. Okay, so the force in the direction of this one, so that you need to find this component, which is F cos theta times the displacement. So that is F cos theta times X, or this is Fx cos theta. Okay, so that's basically, it's in this form, so that's F dot X. Okay, so the work is a scalar as we expected for any dot product. Okay, another thing is, if you do A dot B, which will be same as B dot A, it doesn't matter which order you take the dot product. Now let's learn about the second kind of product in vectors, so that is vector product. The other way to call it is cross product. Okay, let's consider the same vectors, vector A and vector B at an angle theta. The cross product or vector product is written as A cross B. Put a cross in between. Remember, we are putting A dot B for the scalar product, and this is the magnitude of vector A times the magnitude of vector B times sine of the angle between them. And vector product is, the product is a vector. Yes, and the scalar product, the product was scalar, so you don't have to worry about the direction in that case, but here we should. So there's a direction, so that's what we put in here. Okay, so first let's find the magnitude of A cross B if we had the previous numbers, x as the first vector, which is 2 meters, and the second vector is F equals 5 Newton. So this will be 2 times B is 5 and sine 30, and that's the 10 times half, so that's the 5 Newton meter. That's the unit. So what is the direction? So how do we get the vector product's direction? So to do that, we are going to use the right hand. Okay, it could be a little bit confusing when you see me from the other side, but you should use your right hand and place your right hand with your index finger along the direction of the first vector. Okay, place your index finger in the direction of the first vector and place the middle finger in the direction of the second vector, and the thumb will show you the direction of the vector. So in this case, it's pointing out of the page. So that's the vector direction. Okay. So basically what you do is place your index finger in the direction of the first vector, whichever order it's coming. So first vector A, and the second finger, the middle finger, is placed in the direction of vector B, and the thumb will show you the direction of the A cross B. Or there's another way to do the same. Place your fingers, all fingers, in the direction of vector A and curl your fingers into vector B. So this is the only way I can curl my fingers into vector B, in the direction of vector B. If I place my fingers here, so I can't curl my fingers back, so I should place my fingers this way and then curl my fingers into the direction into vector B, and the thumb is showing the direction. So in both ways you end up with the same answer as the direction. So the direction is pointing away out of the page. Okay. And another thing about vector A cross B is A cross B is equals negative of B cross A. So the order matters, so the direction will be opposite. So for example, if I'm finding B cross A, to find the direction, so if I'm finding the B cross A, to find the direction, so the magnitude will be same because it's A times B times sine theta. It doesn't matter which order you multiply, but the direction, you should place your fingers in the direction of B and then curl your fingers into A. So that means your finger, the thumb, is pointing in the opposite direction, that's into the page. Okay, so the direction of B cross A is opposite to that of A cross B, so it's a negative of that one. Okay, and another thing, if you look carefully at this one, what is this B sine theta? So this A cross B is A times B sine theta. What is this B sine theta? So that's actually the perpendicular component of this vector B. So this is B sine theta. Okay, so it's basically A times the perpendicular component of B. Or this actually, if you know the parallelogram, so if you have A and B, and if you construct a parallelogram with A and B as the sides of it, so that's the parallelogram you make, and the area of the parallelogram is this side, that's A, times the height, the vertical height, and the vertical height, if you look at this one, that's the perpendicular component. If this angle is theta, so that's component is B sine theta. So the vector product is giving us the area of the parallelogram of which the sides are vector A and vector B. So are there any physical examples that you can use this cross product? Yes, of course. If when you're finding the moment of a force or torque, that's the same thing, and you're using basically the cross product there. Suppose you have a door, that's the rotation axis of the door, that's where the hinge is, and this is the door, and then you apply a force in here. Okay, So this is the place. This is at a distance r away from the hinge, from the rotation axis. And if you're familiar with the rotation stuff, you know that the force which is perpendicular to the force which is perpendicular to this moment arm or the lever arm is what it brings rotation. So how hard you pull it along the door, parallel to the door, it won't rotate the door. So only the component which is perpendicular, the force component which is perpendicular to this one is important. So how do we find the perpendicular component? So this is the r vector, so that's in this direction, and the angle between them is theta. So we can split this f into two components, which is it's done like this, and this component is f sine theta. So only this component brings rotation, and the torque or moment of force is calculated using the moment arm r times f sine theta. So this is nothing but r cross f. Okay, so this is one physical example where you use the cross product, and there are some other examples as well, but this is one easy examples for you guys. Okay, in summary, there are two different kinds of products for vectors. One is scalar product and one is vector. Another one is vector product. Scalar product, another name is dot product, gives answer as a scalar, and it's calculated as IB cos theta. And the vector product or the cross product is calculated using this equation AB sin theta, and that's a vector, and you need to find the direction using the right hand rule.